Welcome to The Explainer. Today, we're diving headfirst into the high-stakes, incredibly high-pressure world of massive engineering, procurement, and construction projects. We're talking specifically about the big leagues here, the oil and gas sector. We are going to uncover exactly how master planning engineers somehow manage to recover lost time and literally save millions of dollars using Primavera P6. So if you've ever wondered how the pros compress these massive timelines without completely breaking the project, well, you are absolutely in the right place. Okay, let's jump right in. Picture this scenario for a second. You're managing a 14-month, $45 million electrical and instrumentation package for a brand new petrochemical polypropylene unit. Sounds stressful? Well, it gets worse, because the schedule is slipping. The client is staring at those monthly S-curves, and they're demanding answers right now. The pressure is completely on. So how exactly do you claw back that lost time? I'll tell you right now, it is not about just running onto the site and yelling at people to work faster. No way. It requires absolute surgical precision and some seriously advanced schedule optimization.
To figure out how to fix a delay, we kind of have to understand how these massive beasts are built in the first place. Every major refinery or petrochemical plant goes through 5 super rigid phases. And what's really fascinating here is the domino effect between them. Early on, during front-end engineering design, or FEED, you're identifying those long lead procurement items. If you have a delay in those early engineering deliverables, it inevitably crashes right into the massive EPC construction phase later on. Procurement dates drive the construction start dates, period. So a tiny slip early on, it creates a massive tidal wave of delay downstream. All right, moving to Section 1, Foundation, the critical path. Because let's be real, you cannot optimize what isn't linked. Before we even think about shortening a schedule, we have to establish an absolute prerequisite and honestly call out a really common fatal planning habit. If your schedule isn't built on mathematically sound logic, you literally cannot rescue it. A terribly bad approach to planning is misusing constraints. You'll see a planner try to force a target date by slapping a start-on constraint on almost every single construction activity. But doing that, it completely breaks the schedule's ability to react to real-world delays. Good planning means letting the logic and the relationships actually drive the dates. Your schedule has to be a living, breathing network of linked activities, not just some static spreadsheet full of wishful thinking. You should really only be using constraints for genuine external dates, like a vendor-confirmed equipment delivery. So, the absolute crucial concept here is the critical path. By definition, this is the longest logical path through your entire project. If there is a slip here, it delays your final finish date directly, day for day. If you want to shorten a project schedule, you must focus exclusively on the specific chain of activities. Why? Because saving time on a non-critical activity gives you absolutely zero overall project acceleration. None. You have to attack the bottleneck.
Which brings us to Section 2, Schedule Optimization Techniques. Let's look at the big 3 strategies.
Now that our foundation is rock solid, let's open up the toolkit. When a schedule goes off the rails, an advanced P6 planning engineer relies on 3 primary optimization techniques to build a recovery strategy. First up is fast tracking. This means taking activities that normally run sequentially and running them in parallel. The catch? It's high risk. Next is crashing. This is where you add more resources to shorten an activity's duration. The trade-off here? High cost. And finally, logic review. This is simply going in and removing unnecessary constraints or artificial delays. It's beautiful because it reveals true float without adding any extra cost or physical risk.
Let's bring fast tracking to life with a real site example. Imagine you've got a sequential plan. Finish absolutely all the cable trays, and then, only then, start pulling the cables. To fast track that, you just overlap them. You start cable pulling in one sub-area while the cable tray is literally still being bolted together in the next. It absolutely saves time. But remember that risk we just talked about? If the first task hits a snag, say a tray needs to be completely rerouted, you dramatically increase the risk of rework for those cable pullers right behind them.
Okay, now let's talk about crashing. Essentially, this is just throwing money and resources at the problem. For example, say your cable termination activity is dragging on way too long. What do? You add a second termination crew. Because this is what P6 calls a resource-dependent activity, doubling up your electricians literally cuts the duration in half. It shrinks the schedule beautifully. But, of course, there's no free lunch. Your project budget takes a direct hit because you are now paying for a lot more labor or maybe some heavy overtime.
All right, Section 3, What-If Scenarios and Risk. This is all about testing the waters before committing.
Listen, you do not just guess when millions of dollars are on the line, right? This is exactly where the P6 what-if scheduling workflow comes in. The pros always model their crashing or fast-tracking in a safe sandbox environment first. They'll copy the live project entirely, test out all their crazy fast-tracking or crashing ideas in that copy, and then compare the finished dates side by side. Doing this ensures the live-approved baseline stays completely protected while they formulate their master rescue plan.
But hey, here is a massive warning for you when you start shortening a schedule. You absolutely must monitor near-critical paths. It's like playing whack-a-mole. Once you successfully compress your main critical path, a completely hidden secondary path, maybe one that only had 5 to 10 days of float, might suddenly rear its head and become the new bottleneck. Thankfully, P6 allows planners to calculate multiple float paths so these near-critical activities don't just suddenly blindside the entire project.
Let's tie all of this together in Section 4, Case Study, Recovering Time. We're going to save this $45 million polypropylene plant expansion.
Let's drop right back into the exact petrochemical crisis we opened with and execute a rescue operation. Here is the original approved critical path for our substation package. Notice the strict sequential dependency here. We kick off in month 2 with the transformer delivery. That delivery allows month 5 civil works to happen. Then comes switchgear installation, followed by cables pulling, then loop testing, all leading up to the grand finale in month 14, substation energization. That is our baseline.
And boom, here is the crisis. The transformer vendor calls up and confirms a 3-week delivery delay. It's a nightmare because this delivery is a start milestone logically linked to literally everything downstream. So that 3-week delay instantly triggers a 3-week slip on the absolute final project completion date. The client is furious. We need a recovery plan right this second.
So here is the exact 4-step P6 workflow the planner uses to execute the rescue. Step 1, we update the baseline with the vendor delay using a hard constraint. Step 2, we run the schedule to clearly identify that exact 3-week slip on the critical path. Step 3 is our intervention. We target downstream construction activities to try and absorb that procurement delay. Specifically, we decide to use the crashing technique on the cable termination activity. And step 4, we recalculate the P6 schedule to see how much time we actually recovered.
And the result? 2 whole weeks. By crashing the downstream construction, specifically by throwing money at the problem and adding that second crew to the cable termination activity, the planner successfully claws back 2 of those 3 lost weeks. They absorbed a massive upstream procurement delay by strategically accelerating downstream construction. They saved the project from critical failure and honestly proved the incredible value of having an integrated, logically driven schedule.
Which brings us to our final takeaway for today. Ask yourself, is your schedule truly logic-driven, or is it just a series of hopeful constraints? Shortening a project schedule, as we've seen, isn't magic. It's math, it's logic, and it's highly strategic execution. I really challenge you to look at your own planning habits. Are you letting the logic drive your dates so you can actually optimize them when disaster inevitably strikes? Thank you so much for tuning into this explainer, and definitely keep exploring these advanced techniques. Catch you next time.